Hello guys, welcome to drilling-academy.com. I have had another video explaining driller methods well control that is more for surface BOP with a few brief notes for Subsea BOP inserted in it. Then I received suggestions from people to make a dedicated driller's method well control slideshow for Subsea BOP so that it's easier for viewers to follow. So here we go guys, this video is made with dedication driller's method well control for Subsea BOP. Let's start. In principle, there are two circulations as with surface BOP. The first one is to get the influx out of the well by using the same fluid in the hole. The second circulation is to displace the entire system to QMUT. Not much different from surface BOP, but only a few important phenomena. First is when gas hits choke line, this part here, we expect to see drill pipe pressure gauge to drop maximum an amount of choke line friction loss because choke line is displaced by gas, by influx. Alright, therefore we need to close the choking to compensate for the loss of choke line friction loss. Second point is when gas is out of the choke line and mud, the same mud as in the hole is filling up the choke line, this part here. With the choke being closed a little bit, we expect to see drill pipe pressure gauge to increase maximum amount of initial circulating pressure plus choke line friction loss because now mud is filling up the choke line, choke line friction loss is coming back into play. And then after we finish the first circulation, we start the second circulation, QMUT is going downstream. And when it comes around, the annulus comes up to the BOP. And when the new QMUT is starting to fill up inside the choke line, we expect the drill pipe pressure gauge to increase. This is the increment of pressure on the drill pipe gauge. We expect to see it increase maximum amount of new choke line friction loss. So that will be final circulating pressure plus new choke line friction loss because now the new heavier QMUT is filling up inside the choke line. It creates a new choke line friction loss. How to work out this new choke line friction loss? The later slideshows will explain the process how to work it out. It's quite simple. Alright, these choke adjustments are necessary to keep constant bottom pressure. Bottom pressure is all we are trying to keep control here. Alright, the process is a little bit complex, therefore the narrative, the operational steps in this video will be a bit longer than those of the surface BOP because by nature it is longer and there's more things to talk about. Therefore, please be patient, but you'll be rewarded at the end of the slideshow with explanations, information, and of course, knowledge. Now let's go into detail of these steps. So here are a few prerequisites before we start. For Subsea BOP, there are a few things we need to do before we start circulating the influx out and killing the well. First is after shutting in on the upper annular on LMRP, we proceed to hang off drill string on ram BOP on the stack. Alright, this is to prevent wear and tear of drill string reciprocation on the upper annular BOP on the LMRP. The second thing is if choke line and Q lines are containing seawater or glycol, then you need to note down the adjustment on shut-in casing pressure. The true shut-in casing pressure is adjusted by the difference of density in the mud in the hole and the density of the fluid in the choke line and the Q line. Alright, This is the formula for adjustment. Alright, so after that, you need to displace the choke line and Q line to the same mud as in the hole, for the sake of easy monitoring pressure. These are recommended to be performed before we start the first circulation. A few basics about calculation of Q mud weight here. This formula, ICP, initial circulating pressure, you take the slow circulating pump rate of the riser plus shut and drill pipe pressure. Final circulating pressure, you take the slow circulating pump rate of the riser, right, times Q mud weight divided by mud weight in the well. Then you determine the mass. Now your choke line and Q lines are already flush with the same mud as in the hole. Therefore, you just simply using these formulas here to work out the mass. And remember, when you have choke line friction loss effect on the mass, here we call it dynamic mass. Take the choke line friction loss off the mass, alright, when you are bringing the pumps on. Put it back in when you bring in the pumps off. And how to work out the choke line friction loss, you use this formula here. So slow circulating pump rate of the riser deducts slow circulating pump rate of the choke line. And as we mentioned before, we take the choke line friction loss off the casing pressure gauge when pump is bringing on. When pump is bringing off, you stay with casing pressure gauge, put the choke line friction loss back in. Or you can stick with the pressure gauge on the Q line to monitor pressure. Just be noticed that if you're using Q line to monitor pressure, when gas reaches BOP, we need to isolate the Q line to avoid gas migrating into Q line. That's just only one point. Alright, now we can start. Oh, just one more note about the lag time. Because the choke is on the back side, the annulus side of the well. So therefore, choke adjustment requires almost instant pressure change reaction on the casing pressure gauge. But for drill pipe pressure gauge, the response speed is lag behind. The lag time is 1 second per 1,000 of well measured depth. Pressure has to travel down on the back side, come inside the drill string up into the gauge. So to work out the lag time, you take the well measured depth times 2 and divide it by 1,000, and you get the seconds of lag time. While controlling the choke, please be patient for your lag time to see reaction on the drill pipe gauge. This patience is very much necessary to avoid messing around with the choke control. Now, remember we talk about choke line friction loss. You need to mark down choke line friction loss. Alright, decrement from mass. You take it off, right? We also take choke line friction loss off from certain casing pressure, and you also have certain drill pipe pressure. Mark them down on the gauge, alright? And because those are the marks that we use for our safety margin, and we expect to see what happening on the gauges. So stage number 1, we bring the pump up to Q rate. What do? We bring the pump up 5-10 strokes per minute until Q rate. While doing that, of course, run the pump first, crack open the choke. Alright, stick with casing pressure gauge. Now you stick with casing pressure gauge and you take choke line friction loss off, trying to stay around this figure here. Certain casing pressure deduct choke line friction loss. This will help you stay with constant burning hole pressure above formation pressure. During this process, pump is brought up to Q rate. We expect to see drill pipe pressure gauge increase from certain drip pipe pressure until ICP, initial circulating pressure. All right. So let's look at the graph and the gauges, how they progress. Pump rate is a red line being brought up to Q rate. Drip pipe pressure gauge green line is shot up from certain drip pipe pressure to ICP, and we try to stay constant around certain initial certain casing pressure, deduct choke line friction loss here. All right, this process is very short. All right, next stage is continue pumping at Q rate to circulate the influx out of the well. Okay, during this process we call it stage 2. All right, we break each circulation into stages so that it's easier for us to follow and to master what's happening and what is to be expected. Okay, while the influx is traveling up to the BOP here, we expect to control the choke to keep drip pipe pressure gauge constant or about 50 to 100 psi above initial circulating pressure. This will help us to stay with constant bottom pressure a little bit above formation pressure. During this process, we expect to see casing pressure gauge increase. Now, casing pressure gauge is increased, right? While the influx is still below the shoe, here is the shoe, right? We are limited by mass deducted an amount of choke line friction loss to avoid breaking down the shoe. But after the influx is above the shoe, we are not constrained by this value anymore, right? Because influx is above the shoe. When influx reaches to the BOP at the seabed, the casing pressure is high, but it is not maxed out yet. This is the difference from surface BOP. Right? So this is a little bit tricky now. That is when this gas, this influx starts getting into choke line. We expect to see drip pipe pressure gauge drop an amount of choke line friction loss because gas is filling in the choke line. That's why we need to close the choke in a little to compensate for the loss of choke line friction loss. And as gas travels filling up the choke line, casing pressure gauge here, this part here, continue to increase to maximum. And when gas is out, now gas is out the choke line, casing pressure gauge drops. How much does it drop to? We expect it drops down to minimum at the value of initial certain drip pipe pressure here. And because now gas is out of the choke line, mud is filling in the choke line. If we leave the choke open, we will expect to see drip pipe pressure gauge increase. Here, this part here increase. An amount of what? An amount of choke line friction loss because mud is filling in the choke line. Choke line friction loss comes back into play. If now your casing pressure gauge is below MASP, all right, we know that it drops down to certain drip pipe pressure, but if it is below MASP, deduct choke line friction loss now because choke line friction loss come back, right? Then you can leave the choke there. But if you are not comfortable, you see the casing pressure gauge is high, you can open the choke to take off choke line friction loss to return the drip pipe pressure gauge down to initial circulating pressure here. Here is open the choke a little bit here. So this will return the bottom pressure down to where it was before. All right, we keep it constant. All right, is clear here? I hope it's all clear here. Next is we can shut it down here now because the influx is out the well, or we can keep pumping. In this example, we keep pumping. If we keep pumping, what do we expect to see? We expect to keep the same pump rate. We expect to see casing pressure gauge constant at the last value, which is certain drill pipe pressure. And we expect to control the choke, to keep drill pipe pressure gauge constant at ICP here. All right, look at the progressing of the graph. All right. Now our cumulus is ready to be pumped down the drill string. We will start circulating it. You note down your surface line volumes and then work it out into your stroke. How many strokes after you reach the surface line volume stroke, you reset your stroke counter. So that now, because the graph is calculated from the cumulus reach at the surface and the RKB down to the bottom of the well, not counting the surface line volume. All right, so now we start pumping cumulus down the hole from top of the top right at the RKB. All right, we keep the pump running at the Q rate. Right, so we expect the red line to be constant. And while pump cumulus is traveling down from the top of the drill string to the bit, we expect to see the drill pipe pressure dropping by itself. You can leave the choke alone by itself. Now don't touch the choke, and it will drop by the graph, your calculated graph, right? And during cumulus is traveling inside the drill string, outside on the annulus you have homogeneous old mud, original mud. So we expect to see the casing pressure staying constant at the last shown value, which is around the initial drill pipe pressure. Let's look at the graph and the gauges now. See, cumulus is coming down on the string, coming to the bit. The green line is the drill pipe pressure gauge is dropping, and your drill pipe pressure drops from initial circulating pressure down to final circulating pressure FCP here. And your casing pressure here is staying pretty much constant at around certain drill pipe pressure here. All right, that's when the cumulus reaches the bit. All right, now the cumulus starts coming out to the bit, which is another stage. What do we expect to see? When the cumulus starts filling in the annulus, we expect to see casing pressure reduce. This purple line, we expect to see it reduce. We will keep the pump running at the same Q rate, so we expect to see this red line constant, and we expect to see the green line, which is drill pipe pressure gauge, to staying constant at last shown value, which is the FCP here. All right, now let's look at this graph. Okay, keep moving. All right, now cumulus is filling up on the backside annulus. You see the graph is happening exactly as what we said before. Now cumulus has reached to the BOP. When the next stage is when cumulus starts going into this choke line. All right, this is something going to happen here. It's different from the surface BOP because we have a decent water depth and air gap. This is quite considerable distance, right? So we expect the drill pipe pressure gauge to increase. How much does it increase to? It will increase to a new value of choke line friction loss because cumulus is filling into this choke line. It creates a new choke line friction loss. All right, and casing pressure, we expect to see it continue to drop down to zero. And what about pump rate? We keep running at the same pump rate, right? So let's look at the gauges and the graphs. See green line, which is drill pipe pressure gauge increasing to the FCP plus the new choke line friction loss, and then we keep pumping. Right, drill casing pressure drops, that's zero. So this is the formula how to work out the choke line, the new choke line friction loss. Right, you take the old choke line friction loss, you time cumulus weight divided by ultimate weight. And now you can shut the pump down, all right? Because this is the end of the second circulation. Qmat is all the way around. Okay, when we shut down, everything comes down to zero. So that's it. That's the end of second circulation. For surface BOP, we are done here. Here we can start opening the choke fully and flow check the well through the choke, all right? But now for this subsea well, we still have a few more tasks to do, all right? Which is to fill the other parts of the choke line. This choke line here, we fill the other parts of it with the Qmat, and then we remove the trapped gas in the stack. This is subsea stack, so there might be trapped gas in the stack here, and then we will flush the Q line, all the parts of the Q line with the Qmat. All right, now so let's take a closer look at how things are configured in Subsea BOP here. So this is the end of at the end of the second circulation. The purple is a Qmat. It comes up here, it pushes the ultimate here, and the gases everything out of the choke line. So now let's look at here. Right, this part is ram where you hang off your real screen on it, and this yellow part here is the gas trapped in the stack. This part of the choke line is filled up with Qmat. I'm sorry, my tongue tricked me. But this part of the choke line is not. It's still filled up with ultimate. And the Q line, all of it, the Q line and its part are still filled up with the ultimate. So our task is to fill up all the other parts of the choke line with Qmat. Okay, that's the first step. What we're gonna do? We're gonna close these two valves, open these two valves, pump down the drill string, take the return of the choke line. So that's how we displace all the other parts, the lower parts of the choke line into Qmat. Now let's look at the animation. See, it's closed, it's open, fill up with Qmat, and then we will reopen these two valves and close these two valves, return them to original positions. All right. So now the whole choke line and all of these parts are all filled up with Qmat. Now we proceed to remove the gas strap in here and then displace the Q line and all of its part to Qmat. For these two tasks here, please refer to my video of removal gas trapped in BOP, Subsea BOP stack in the same in my channel, or you visit my website at drilling-academy.com for the detail of steps how to perform these two tasks. We're not gonna go into those two tasks in here because they are a little bit lengthy and takes more time. It's about 12-13 minutes. We don't want you to fall asleep in this presentation. All right, guys. So thank you very much, and I hope you guys did get some useful information out of this video and all the slideshow in slow motion mode. If you have any queries or questions or comments or discussion that you would like to bring up, just feel free to send them to my email address at rich.tron01@yahoo.com.sg. I'll respond to you. I'll see you soon in the next video. Thank you and bye-bye.